Good afternoon, everybody. It's Pat Telford again. If it's not afternoon when you're watching this, you got three choices. You can either pretend it's afternoon, you can ignore what I just said, or you can wait till it's afternoon. I'm going to carry on regardless, though. So in this session, we're going to talk about business continuity and disaster recovery. So how do you protect the Azure Stack itself and workloads running on top of it from something that might go wrong? So we're going to talk about the backup and recovery of the infrastructure, the configuration of Azure Stack itself. We're going to talk about some patterns for high availability. We're going to talk about how you might handle the backup and the restore of the running user workloads. And we're going to talk about how to protect platform as a service workloads and how DevOps can help in your journey to recovering from a disaster. So the first thing is, what is the philosophy for business continuity and disaster recovery when it comes to Azure Stack? So you're going to see it's a mix of tools and techniques and capabilities. It's not a perfect story today, but there are tools and techniques that are getting better over time as Azure Stack matures. So what are we going to talk about? We're going to look at, as a user, so someone that's deploying and running and experiencing their own workloads running on Azure Stack, they need to be able to protect their running workloads, both for virtual machines and for platform as a service, so websites, databases, etc. From an operator perspective in Azure Stack, you want to know that if there is a real disaster and the stack is destroyed or damaged or unrecoverable, that you will be able to get back to the state of Azure Stack before the disaster. So just a few terms about BCDR before we get started. So business continuity and disaster recovery are related terms. It's basically going to describe how you as an organization would recover from something that goes wrong. So it could be a fire in the data center. It could be some massive power failure. It could be a physical disaster like an earthquake or a tsunami or something like that. It's not just technology. So it's largely driven by people, process, and doing things. And a good example of that is at one of my customers, when they practice their disaster recovery scenario, what they do is they identify all the people that would be involved in recovering from a disaster, and they randomly select a proportion of them, I think about a third of them, to not participate, because that's something that would happen in a real disaster. People would be unable to get in, power might be out, those sorts of things. So you can see that's nothing to do with technology at all. That's just a natural consequence of trying to recover when something bad happens, if it's a physical disaster like an earthquake. So we're going to talk about availability at the site level, and we're going to talk about fault tolerance within a scale unit of Azure Stack and what happens to work on top of it. So we're going to start like a movie. We're going to start from a vision far back from your data center, the site where an Azure Stack might be deployed. So normally at that site, there will be power coming in to one side of the site. So all the things that are needed to run, condition the atmosphere, etc., to have your data center be up and in most data centers that will be redundant. So there will be two paths for power, two paths for network, all those sorts of things. So if one side gets knocked out of commission for whatever reason, all the facilities to the data center will still survive. Inside that data center, we're going to pretend is where you have an Azure Stack cloud deployed. You may have multiple instances of Azure Stack running inside that data center. Just keep in mind that, as we said before, today with Azure Stack, each individual scale unit is its own cloud. There's no glue that lets you stick together multiple Azure Stack instances into a single region or a multi-region cloud today. They are each treated as if they're completely separate units. You can build hybrid workloads that span multiple Azure Stack instances, but you cannot manage them all as one entity. There's no single pane of glass, a single portal that lets you work against them all. So if we imagine there's a site level failure, we could call that the impact radius of your disaster. So the whole data center is gone. And we'll talk about how Azure Stack can recover failure in a little bit. Now, if we zoom our movie camera in and we look inside that data center, you might imagine an Azure Stack is there. So an Azure Stack will be a single rack with a bunch of server nodes in it and some network switches. So within an Azure Stack scale unit, there will be multiple power distribution units. So inside the rack, if power fails on one side, everything can still be powered by the other side. And those would be discretely powered by the two separate electrical capabilities of the data center itself. So an Azure Stack can survive failure of that. Now, inside the scale unit, which would be the part in the blue rack, there will be a number of server nodes, the black rectangles there, up to 16 of them. The extra bonus server, which is the hardware lifecycle host, there will be a switch that's connected to the servers and the HLH to monitor the hardware level activities inside the stack and provide alerting on the hardware. And then there will be two network switches at the top of the rack. So we call these top of rack switches or leaf switches. Outside of that, there will be the border devices, the networking within the data center that the Azure Stack is connected to. So those two white switches at the top, those would be existing devices on the customer premises. Keep in mind, as I said before, you can't split a scale unit. It all exists within one rack. You can't move part of it over to another rack. It's all integrated, tightly coupled with networking to allow Windows Server software-defined capabilities to manage the storage, the connectivity, the networking. So there's no splitting of a scale unit. You can have multiple scale units, so two Azure Stack instances. Today, they're completely separate. Within a scale unit, there's good redundancy. So there are two top of rack switches. If either one of them fails, all the server nodes will stay fully connected. You won't lose any networking capabilities if one whole switch fails. There are between 4 and 16 individual server nodes within the scale unit. There's pre-reserved capacity for one whole server node's resources to fail and disappear, and there's enough capacity reserved in the remaining nodes to host all the running workloads and all the fabric of Azure Stack. We use Windows Server clustering technology as well as storage spaces direct to make sure that storage is visible to all servers within the array. And those 16 servers, or up to 16 servers, are connected together in a cluster so that if one node fails, the workloads running on that cluster can be brought up on another node because their storage is distributed across the whole Azure Stack. There are a couple things that have individual failures. So there's that BMC switch. It's the switch that connects the hardware lifecycle host to each of the server nodes so that the OEMs can provide their own special sauce for monitoring hardware level failures. So this would be like the DRAC or the monitoring systems that the OEMs would normally provide for their regular server environments. So that switch is a single point of failure, but it's not crucial to the operation of Azure Stack. If it disappears, all we lose is the monitoring capabilities for the OEM specific monitoring. And the hardware lifecycle host as well, that's where those monitoring tools will run from. If that server node fails, it can be reconstructed and you'll just be without that extra little bit of monitoring while the server is unavailable. So those are the main single points of failure, but they're not crucial to the operation of Azure Stack. So let's look a bit more with the unit itself. So if you pull out a server and look at it, each server must have at least two network interfaces. Those NICs will be connected to two different switches at the top of the rack. You can also see there's a network interface at the bottom. That's the BMC network port. It will be connected to the BMC switch, again, just for hardware monitoring. Each server has dual power supply connections. So again, they'll be connected to different PDUs in the rack, and those PDUs will be connected to different power coming into the data center. The server nodes also normally have two boot drives internal. So they'll be redundant at the disk level inside the server. So you can lose one power side, you can lose one NIC, you can lose one of the boot drives, and the node will still be able to boot and operate fine. You'll get alerts in the console, and alerts will be emitted from Azure Stack. But just to recap here, the architecture of Azure Stack as it exists today, you're going to deploy into a site, so a location, and inside that location is going to be a data center, and you're going to deploy a rack with Azure Stack inside it. Now, today, Azure Stack is each scale unit of Azure Stack, each rack full of Azure Stack is one region in one cloud. So there's no such thing as a multi-region Azure Stack deployment yet, and there's no such thing yet as adding additional scale units to an Azure Stack region itself. So each cloud is basically a single instance of Azure Stack. It's got a single portal, a single ARM endpoint. So one scale unit per region, and inside the scale unit, you will have between 4 and 16 server nodes. On top of that, your application workloads will run, and the Azure Stack services that are running as the fabric of Azure Stack are virtual machines running on top of Windows Server. So one of the questions that comes up for organizations deploying Azure Stack that are familiar with deploying a hypervisor, so whether that's VMware or Hyper-V or any other hypervisor, is they're used to taking snapshot backups of running workloads on top of that hypervisor. So they say, hey, can I still do the same thing as I did to protect workloads running on a hypervisor? The answer to that is no. So just like in public Azure, we do not allow any access to the host operating system to take snapshot backups. So protecting your workloads, even protecting the infrastructure of Azure Stack, is going to be fundamentally different than what you might be used to if you're used to running a VMware estate or a set of Hyper-V servers. The reason for this is that, as you saw before in the patch and update cycle, we don't let any additional tools run in the server nodes. Only the Azure Stack software, so that's Windows Server plus the Fabric virtual machines. Those are the only things that we allow to run in the base underlying operating system for Azure Stack. And you can see why. If we let somebody run a backup agent on the server nodes themselves inside Azure Stack, every month we come along and we stamp on top of those. We don't patch them, we wipe them and reload them. So there's no real possibility to include additional software in those underlying server nodes. So that means you're going to have to rely on operations that occur either governed by the Azure Stack software itself, or as guests that run in virtual machines, or as agents inside the VM workloads running on Azure Stack. So basically the OEMs are the only ones that can deliver an Azure Stack, and the recovery of Azure Stack is going to be governed by them as well. The other thing to keep in mind is we don't let you put additional tools on top of it. You need to manage Azure Stack through the admin portal or through PowerShell. So all the software running in the Fabric and on the nodes is whitelisted by Microsoft as part of the security of Azure Stack. So there's no introducing third-party agents right down at the base level of Azure Stack itself. You can introduce them as agents running inside the workload VMs, in the guest type of VMs, but you can't put any agents inside the fabric of Azure Stack. So the other question is there some sort of catch-all? Can I take one big backup of Azure Stack and store it somewhere and then just redeploy it and get back to the state that it was in? And the answer to that is no. So there's going to be two parts to doing a complete backup of Azure Stack. One is to back up the configuration of Azure Stack itself, the fabric. The other one is to back up the workloads themselves, so the VMs. So there's no mechanism like there is in public Azure with redundant storage split across multiple locations to protect your workloads. That's not available in Azure Stack yet, because we don't have a multi-region single cloud for Azure Stack yet. Obviously, In addition to being able to back up virtual machines, you might need to back up other types of workloads. So containers, websites, those sorts of things, database tables, all those sorts of things. You might need to be able to back them up as well. No sort of one stop for backup. First here, we're going to talk about backing up the Azure Stack infrastructure. So this is as an operator, you've received your OEM deployed Azure Stack. You've done a bunch of work inside there. You've set up quotas and plans and offers. You've registered the Azure Stack. You set up a bunch of configurations specific to your Azure Stack. You may need to back all of that up so that in the event of a real disaster, your Azure Stack burns to the ground, you can then at least get back to the starting point with all that work you've done as an operator. You're not going to have any workloads deployed on top. Get back to your place when your initial work before workload number one came in as an operator. So this is called an infrastructure backup of Azure Stack itself. There's a resource provider that manages these backups. It's a full backup each time, no incremental. Each backup is about 10 gigabytes. The backup itself is encrypted, so you're going to store it somewhere off Azure Stack, which I'll tell you in a second. You don't need to worry about that. It's encrypted using a certificate now. So as long as you have access to that certificate, you can decrypt it during a recovery process. In version 18.07 of Azure Stack, we introduced a bunch of things to make the backup management easier. So it'll be automatically scheduled, and there's nice configuration in the portal. I'll show you a little screenshot of that. The backup does not include stuff that's running off of the Windows server. So it doesn't include the switch configuration or anything on the hardware lifecycle host to do with the OEM specific hardware monitoring solution. So the OEMs themselves can also have specific backup steps that you might take to grab those configurations so that they can be restored nicely in the event of a disaster. So on your right here, you'll see the blade that you'd get as an operator in the portal for Azure Stack. We recommend taking at least 2 backups a day, and the share that you're targeting to hold those backups should be able to hold at least 140 gig. So 2 backups per day for a week at least. You can see the items that you'll have to enter in when you're configuring it tell you how it works. So you're going to give the IP address and the name of a share. So this is like an SMB network file share somewhere on your network outside of Azure Stack. You're going to give it a username and a password to connect to that share. And then you set how often you want to do the backup and how many days worth of retention you want to keep. So these are the defaults. You're going to back up twice a day for 7 days. That's 14 backups at 10 gig apiece. So you need 140 gigabyte of backup space. That little box at the bottom there is the encryption key. You used to have to put this string into that box and keep that string somewhere else. That's to encrypt and decrypt it. Now you can actually select, instead of this encryption key, you select a certificate that's used to encrypt the backup, and then you later have to recover that certificate so that you can restore it. So a few more things, just to drill down into what I said. You as an operator need to provide an SMB file share with, it says here, at least 1 terabyte of capacity. The backups are probably going to take about 140 gigabytes if you use the default. If you have separate deployments, like if you have multiple Azure Stack instances, they can all create their backups in the same place. They'll create a subfolder that's tagged with the name of your Azure Stack deployment. And it obviously says, don't host it on the HLH or a virtual machine inside your Azure Stack environment. Because if it's a real disaster, you're probably going to lose both the hardware lifecycle host and the whole Azure Stack. So it needs to be backed up to somewhere separate. We do not currently support backing up to Azure files. You need a username and password to connect to the share, and you use a certificate to provide the encryption. So in that blade that I showed you, you're going to enter all. And here's some examples of what gets stored in that file server. So you can see in this case, we're connecting to a file share on the server fs01.contoso.com with a share name of AZS backups. or AZS backups if you're Canadian like I am. The content in there, it is going to back up all the infrastructure information enough to restore an Azure Stack fabric, so all the operator settings in the event of a disaster. And it can contain a bunch of sub-information. So information about regions, information about the backup, information about the hardware lifecycle host itself, the software configuration related to the switches, the files that you used initially to provide all the answers for your very first deployment of Azure Stack. So the things like the region names, the public IP address space, those things are all in there, all the certificates that are included, and the activation. So the activation will be preserved if you ever have to do a restore. So basically, there's a whole bunch of information that you've already entered at least one time into Azure Stack in a standard file structure in that backup share. So this is only infrastructure, only configuration of the Azure Stack server itself. You don't normally need to interact with it. You set it up once and forget it. It will fire an alert that you will see in the dashboard if the backup fails for any reason. And like everything else, trigger it with PowerShell as well. So you should have enough disk space. We don't support Azure files, and you need to be able to keep the encryption key. So in this case, it's now a certificate. It's not a string. So here's some examples. So this is a configurable frequency for backups, like I showed you. If you need to recover from that backup, there is now the capability to take the backup on a multi-node production Azure Stack instance. And obviously, if you're rehearsing your disaster recovery, you'll want to restore it someplace. But you probably don't have another multi-node Azure Stack just hanging around just to run this test once a year. So you can use the Azure Stack development kit, so deployed on a single server node, and it can suck up the infrastructure backup data from a multi-node Azure Stack instance and do a pretend restore onto it. So this is a good way to be able to test your disaster recovery process without having a lot of hardware hanging around. So now the certificate is used to back up the key, and eventually we'll get to the point of supporting Azure files. So we're not there yet, but that's coming. Now, I mentioned that the OEM has their own secret sauce included in the Azure Stack. So this is in the hardware lifecycle host, that little bonus server that's sitting in the rack beside Azure Stack. So the OEMs themselves will have processes to trigger to perform a backup of that infrastructure that can be used again to configuration back onto that hardware lifecycle host during a recovery. So let's pretend you've had a disaster and you've got your backup set aside somewhere on a file server, and now you have to go through the recovery. What does that look like? So this is a long-winded process because, first of all, you need to obtain a new Azure Stack. So you're going to have to order it. It's going to have to be built. It's going to have to be shipped. And like the initial install of Azure Stack, professional services from the OEM will be involved in the initial installation. So they'll come on site and they'll work with you. That might take several weeks, depending on the order process and the backlog and all that sort of stuff. Then they're going to do an installation of Azure Stack, just like they did the first time, except this time they're going to answer a question that says they're going to do a cloud recovery, which means basically, instead of answering all the questions, as if in an initial deployment, I'm going to consume the backup information from a previously backed up Azure Stack scale unit. So that information is used to do all the initial configuration, including all the extra stuff you did as an operator. So all your plans and offers will come up. It'll be activated already, etc. Once that's done, the base installation of Azure Stack will be complete. They need to do a platform as a service restore, right? So you've got the resource providers. So you'll need to install the resource providers, and then that configuration also needs to be restored. And the last part is not covered by the infrastructure backup. This is the user workloads. So to get the fully functioning Azure Stack, your user workloads are going to have to be restored. The VMs are going to have to be populated, all those sorts of things. That's another phase that we'll talk about in a second. So the OEM shows up, they perform their baseline installation of Azure Stack. They select cloud recovery mode. It asks for the information. You provide that, and then it will restore all those settings. So here's an example of some of the stuff that's backed up inside the infrastructure backup. It's a backup of your domain controller because it's got all your identities, all the service accounts that are used, everything like that. That's used to bring up the new secret internal domain inside Azure Stack when you do a restore. It's got your deployment ID. It's got the deployment parameters. So all the questions that you answered when you were preparing to install your Azure Stack for the first time. It's got the certificate information. It's got the ADFS configuration. If you chose ADFS as your identity store, so it will automatically reconnect up to the other Active Directory, the other ADFS, without you having to reconfigure it. It knows all the user subscriptions, so it will redeploy all those. It knows all your plans and offers and quotas. It remembers all the secrets that you put in your key vault, because they're all just stored in software on Azure Stack. It knows all the role-based access control you set up. And the resource groups are in the user space, so they're not included in the backup. So the workloads that are running in those resource groups will have to be redeployed in user space. And resource groups that were created after the backup was taken will be just automatically re-added into the list. So once they appear as part of the user restore, those can be recreated automatically. So as I said, if you want to test it, you can take your backup and you can do a cloud recovery deployment on your ASDK instance. Just answer a question in the ASDK deployment. So what about some other methods for high availability that rely on things that are off of Azure Stack? So can we do disaster recovery between Azure Stack and Azure? And the answer is yes, we can. So the workloads running on an Azure Stack can take advantage of Azure Site Recovery and have them protected in Azure. So that means if your Azure Stack fails, you can elect to fail those workloads over to public Azure. Azure Backup can also be used to take backup of running workloads and store the backups in Azure. So that's in the user space, the user VMs. If you're a service provider, you can also offer some of those services yourself. So you can offer to host additional copies of those workloads running in your location and just repoint the customer workloads to yourself using DNS, for example. Some sort of high availability or redundancy. One thing that you cannot do is you cannot host Azure Site Recovery as a target on Azure Stack. So that means you can't provide protection for workloads that are running somewhere else so that they fail over onto Azure Stack. And it also means that you can't protect workloads running on Azure Stack and fail them over using Azure Site Recovery to another Azure Stack. The only valid target is Azure. So if you think of Azure Stack as a client for Azure Site Recovery, the only server side, the only service is public Azure. Now, it is possible to provide application level redundancy between two Azure Stacks. So you imagine you have a website and you want to provide redundancy. So you would have one copy of the website running on Azure Stack Scale Unit 1, another copy running on Azure Stack Scale Unit 2, and you'd have a DNS entry out in front of them that could load balance or switch incoming user requests between the two Azure Stacks. So that's building in some redundancy with a hybrid application pattern that you could run against two Azure Stacks. So another possibility is you could do some disaster recovery, right? So you could have workloads running in standby on a second Azure Stack. And if the first Azure Stack suffers a disaster, those workloads could be brought up. Those VMs could be brought up, for example, on another Azure Stack. So you back up the VM, you have it restored on the other Azure Stack, you bring it up. Obviously, the data loss, your restore point objective, will be variable depending on how often you're backing up and how you're doing it. And your downtime will be how long would it take you to repoint your users to the new workload running on the other side. So obviously, the further away you are, the more latency you have, the more bandwidth might be required. That might affect your ability to shrink down your restore point objective towards 0, and it might take longer to bring them. Just all normal workload data center considerations. Nothing unusual there about Azure Stack. So let's look at what happens in user space. So as a user, you're concerned about your workloads running on Azure Stack. How do I back them up? How do I restore them? How do I make all those sorts of things? So for SQL Server, we'll look at a few scenarios. So let's say you have a SQL Server database running in one location. Ideally, you would have a copy of that SQL database running at a second location. So that could be in a second Azure Stack instance at another data center. And you'd have a web application that's connecting to the database, and it's load balancing across the two database instances. So you'd use normal SQL Server availability techniques to do this. So you can use a SQL always on configuration, which means that there are multiple copies of the database always being written to. And if one of them disappears, that always on resource name will direct you to one of the replicas that's still running. So that's a perfectly valid configuration for Azure Stack. It just relies on SQL always on. It doesn't rely on anything particularly built. So what about site-to-site recovery behind a VPN? So in this case, you might have a workload running in a private IP address space with a SQL database sitting on there. So the regular SQL always on connectivity can't work properly unless you have a VPN in the picture. So in this case, there's a site-to-site VPN between the two instances. Again, you'd use the same sort of technique to make the database highly available across two data centers. This time with the replication between the two always on instances following that site-to-site VPN. There's another technique called a SQL distributed availability group. So this is sort of two SQL always on instances that are load balanced between them. So there's replication between two SQL always on instances. You can see one is in the Azure Stack at the left and another one is in the Azure Stack at the right, and it's got a single name that front ends it. So again, this is just another variation on the theme. This is all standard SQL high availability techniques. It's just implemented on two Azure Stacks. Okay, and what about app service? So if you're deploying websites, etc. So you've got the app service resource provider installed on your Azure Stack and you want to make it available elsewhere, you can use traditional web load balancing techniques here. So if you have a load balancer external as a device, or maybe even in a SQL Azure load balancer, you can point your users to instances of the website that are running on two Azure Stacks. Again, you have to take care of distributing data, files, or whatever between the two Azure Stack instances. But you can see this is another technique for using a hybrid solution with a load balancer that sits outside of Azure Stack to provide high availability, even if one instance of the Azure Stack fails. So again, two Azure Stacks are two completely separate instances. They're two clouds. So this would be like the same as a hybrid pattern where you had your website running normally in Azure Stack with cloud bursting up to public Azure and a load balancer sitting in front to direct the clients to one or the other of those places. The same thing is going to happen here. So recovery time planning. If you have a running Azure Stack integrated system and you need to recover it, you have the long-winded process I described to you earlier about order new Azure Stack, restore the information on top of it, recreate all the VMs, restore all their backups on top of it. That's obviously going to be a long-running process. The other approach that we've just talked about in the last few slides is maybe you can have application level redundancy so that if the Azure Stack goes away, the application can still survive and have another copy running somewhere else, and you can load balance to it. So that's like a hybrid application approach to recovery from a failure. And all these things are things that you need to consider. How urgent is it for you to recover? What techniques do you use, etc. So again, most of those are just traditional data center, high availability plus BCDR considerations. What about protecting user workloads? I said the Azure Stack infrastructure backup only really takes care of the fabric setup. So the options here are really relying on in-guest techniques. So we mentioned Azure Site Recovery. You can configure Azure Site Recovery for VMs running for workloads on Azure Stack to protect those workloads by Azure Stack Recovery pointing to public. You can also use traditional data center backup and restore tools that use agent-based backup. So they're going to run something in the guest VM or pointed at the guest VM to produce the backup. We can't take a snapshot. We can't take a Hyper-V snapshot because you're not allowed access to the platform underpinning there. So there's a whole range of normal third-party server backup that we've tested with Azure Stack running with agents in the guests. All that stuff. One other possibility is you could use the Microsoft Azure Backup Server. So this is a server that you would normally place into your environment, and it can take local copies of the backups, and it's backed by the Azure Public Cloud Backup Service. So it's a Microsoft example of an agent-based service. Now, one thing about this is that the Azure Backup Server would run as a VM in your user space in Azure Stack, and it would connect to all the servers that it's going to back up. So that server needs to sit in a position in your Azure Stack that it can connect over a network to all the other servers, the servers it's backing up. So that might be a problem in terms of how you lay out your virtual networking. Maybe you need a whole backup LAN where the backup server, the Azure backup server is sitting that can see all the workload VMs. And it would need to see all the workload VMs from all the potential customers. So in a multi-subscription environment or a multi-tenanted environment, this might be a non-starter because there's no necessarily good place to sit the Microsoft Azure backup server that it can see all the rest of the servers. We talked about the VM replication, so we can use Azure Site Recovery. We don't support any APIs to enable snapshotting of the VMs, but we can use any other technique that targets the guest workloads. We had a plug fest with a number of backup solution providers in Redmond, where they worked live with their tools running against our Azure Stack instances. So all these vendors here have solutions that can perform backups or replication or some kind of availability solution. So you can look at these. These are all big vendors in the space. Links to all of their solutions. And then a last couple of topics is, what about just providing some high availability with tools that are in box? So Azure Stack has availability sets that you can apply to infrastructure as a service VMs. So this is basically, you're going to deploy multiple instances of a VM and protect it using normal Windows Server clustering that are available in Azure Stack. So if there's any maintenance and you need to take individual VM nodes down to service them, this is a good option. It's going to appear like a set of clustered virtual machines, so you can take one node out, service it, bring it back into the cluster, take the next node out. So this is basically the same servicing approach as we have in the infrastructure, but in the user space, you can use an availability set to guarantee that those VMs are shuffled between different server nodes. So if one server fails, you need to do maintenance. The application is going to stay up and running. So the ideal case for an application to run inside an availability set is it should be stateless, right? Because when the user comes in, they're going to connect to one of those instances of the VM. So it's no good if a user connects to an instance now, they get disconnected and they come in a few minutes later, and if they don't connect up to the same node, it's the only node that knows about their state. So you have to have a stateless app for this to work. Again, this is the same as planning for availability in Azure. Similarly, how would you protect platform as a service data sources? So this would be app service, SQL, MySQL that we've already talked about. So again, this is all going to be application dependent. So a PaaS service might normally have multiple components. It might have a function or a set of functions that's connecting to a database instance that's feeding a website that users connect to externally. So again, you need to consider the whole scope of your application and perform some kind of backup that gets a consistent state of all the components of your solution at a point in time. Because sometimes it's no good to take a backup of the website and the application server and the SQL database all at different times, because they need to be 100% in alignment if you're going to. So again, there's nothing fancy about Azure Stack here. These are just normal considerations for backing up a running workload wherever you might host it. So there are some techniques and tools to store information about PaaS backups. So you can do automated migration of the backup using the Azure Backup or third-party tools. You can do some manual migration, so copying files around, those sorts of things. There's no such thing as cool storage in Azure Stack, so we don't have that feature that's in public Azure. And lastly, we're going to talk a little bit about DevOps and BCDR. So if you're familiar with DevOps, and you can imagine how you would use DevOps against Azure Stack, you are going to form your workloads. You're going to identify infrastructure as code using Azure Resource Manager templates. So you'll have ARM templates that are able to deploy your application. So you can see how if all of your applications, all of your workloads are deployable via ARM, that means you can easily reinstantiate those applications after a disaster. Obviously, you need to take care of the data. So maybe the data is all held in databases that you'll need to restore separately. But instead of trying to back up and restore individual VMs, maybe you can just redeploy your whole workload using an ARM template. So that might mean you back up the Azure Stack infrastructure. In the event of a disaster, you have a repo with all of your ARM templates in it. So you get your Azure Stack replacement up and running again. And then you just use DevOps to point Visual Studio or whatever release tool you're using at your Azure Stack and deploy however many instances of your application you need using ARM templates. So just the whole idea of automating your installations can help you in a BCDR situation. That's the whole idea, is you should be able to rapidly and easily redeploy an application to any location. The other thing this offers you is maybe your workload normally runs in Azure Stack and you deploy it with ARM templates, but you could take those ARM templates and deploy against Azure Public Cloud and restore your application up there. So in summary, the backups you take are of the infrastructure of Azure Stack to allow you to redeploy it if it burns to the ground. You also need to tackle the backup and restore of your workloads. So a lot of that comes down into the planning of the architecture of your workload, using hybrid application techniques to make it available in more than one place, and being able to restore rapidly, maybe using ARM templates. Here's a bunch of links to other resources related to BCDR and Azure Stack that are available. I hope you've enjoyed this. You can now go on to the next module.